Hello. Have you ever been on a bus going back home or to your work and then suddenly this bus ran out of fuel? I guess the answer is no. But actually, this may happen if the bus that you were on was an electric one. Of course, only in case of improper planning. I'm Ayman Abdelwahed from Erasmus Rotterdam University, and in this short lecture, I'm going to introduce you the problem of transit bus networks electrification. Or in other words, the problem of making the transition from the conventional fossil fuel transit bus networks to the electric ones. And that is our agenda for this lecture. First, in this video, I am going to introduce you the problem and why is it a problem in the first place. Second, in the next video, I will present to you some practical insights from the project of electrifying the transit bus network in the city of Rotterdam in the Netherlands. And finally, I want to end this lecture by opening the discussion with you and think about what could be next in the field of electric transit bus networks. So, let's start and ask the first question. Why is it a problem or difficult to make the transition from the conventional diesel or gas transit bus networks to the electric one? Why don't we, or the public transport operators, just go and replace these conventional buses with electric ones and operate, and that's it? Unfortunately, these electric buses are cleaner, yes, and have zero emissions, less noise, and they provide a sustainable option, but they have two main issues. First, as any electric vehicle, electric buses have a very limited driving range when compared to the conventional fossil fuel buses. Second, they need significantly longer period to recharge their batteries compared to the refueling time of a diesel or a gas bus. Given that, this means that electric buses cannot run for the whole day actually without recharging their batteries for several times. This operational constraint did not exist before with the conventional buses, which normally used to run for the whole day from the beginning of the day, operations in the morning, till the end of the day without needing to refuel their tanks, or maybe fuel it 1 or 2 times at most. So now we need to add recharging sessions in the operational schedules of the electric buses. And due to their slower charging rate, these sessions should also be long enough such that electric buses will have enough time to recharge. And hence, they do not run out of energy while operating. So, what are the possible techniques to recharge these electric buses? The most two common techniques are battery swapping and opportunity charging. Each one has its own pros and cons here. For battery swapping, there is usually a central garage where a bus can go to replace its depleted battery with a fully recharged one. For the opportunity charging, buses recharge their batteries at some stations where there are chargers, so a bus goes at this station and gets connected to a charger during its layover time to get it charged. This can happen either at terminal stations only of the lines when there are no passengers on the bus, or it can also take place at some intermediate stations with passengers on board. But in that case, usually the charging sessions become shorter. Battery swapping is of course faster. As the bus goes in, it replaces its battery and that's it, it's fully charged again. Another advantage is that it gives more flexibility to the operator to decide when to recharge the batteries. For instance, that could be at times when the electricity prices are lower. However, the infrastructure cost in case of battery swapping is significantly higher. To install that whole robotic battery swapping system, it requires a large area of land, and additionally, all the buses in the network should drive to this central station or garage to change the batteries over there, which is not very efficient actually, and it results in a big amount of deadhead driving distances. On the other hand, opportunity charging does not require a big infrastructure cost, and it is very easy to implement. All you need to do is install some chargers at some stations where buses can recharge their batteries. So in this lecture, actually, we are going to mainly focus on the opportunity charging technique only. So now we know that we need to add chargers at some locations and replan the operation in such a way that buses will have long enough layover durations at the stations where there are chargers to recharge their batteries and avoid running out of energy. However, this implies that we need to replan the whole network. This involves needing to make replanning at the different decision levels, starting from the strategic decision level and moving to the tactical and at the operational level as well. As at the strategic level, of course, we need to first decide where we are going to install these chargers. How many of them do we need? Of course, given the land and the capacity constraints. What is going to be their charging power? Also, we need to check if we will have to make any change to the trip schedule which is communicated with the passengers. And this actually should be very minimally affected because passengers should not feel any changes when we make the transition from conventional to electric buses. Then, at the tactical level, there is the bus assignment schedule, or in other words, deciding which bus will perform which trip, and this directly determines the layover profiles of the buses. So the bus assignment schedule needs to guarantee that each bus will have enough layover durations at stations with the chargers. And finally, at the operational level, comes the charging schedule, which is a problem that doesn't exist before with a conventional network. The charging schedule decides when, where, and for how long will each bus recharge its battery during the operation. For instance, you may have 2 chargers and 3 buses at a station, so we need to make a decision which 2 of them will use the chargers. Or the decision might even be that we are not going to charge any of the buses now because the energy prices are high, for example. So it is a new problem that transit network operators need to deal with. And finally, there is also the crew scheduling, which gets affected as well, because now drivers may need to connect and disconnect the buses to the chargers during their break time, so some replanning is required at this stage as well. So that's it. Here comes the answer to our questions that we asked at the beginning. Why transit bus networks electrification is not an easy or a very straightforward problem. And the answer is, as you can see, due to the fact that electric buses need recharging during the day operation, operators need to do a complete replanning for the whole network and need to deal with different planning phases. Each one of these indeed is a very complicated optimization problem. And if we look at the whole system, these problems are also interrelated. So the output of each problem serves as an input to the next. So ideally, we would need to solve all of these problems simultaneously to reach the best or the global optimal solution and the plan for the whole network. However, that is of course practically impossible, as this would result in a huge and very complex optimization problem that is very difficult and hard to solve. And that's it. Thank you.